Hi everyone, how are you all? I hope all of you are doing great. So let's just start our discussion on Q and stack gate PYQs. Okay. So this is for both gate CSE and gate DA students because Q and stack are these two topics are in syllabus for gate CSE and gate D both. Okay. So let's get started this discussion, and we will be basically seeing all the gate PYQs. Okay, so we will be seeing all all gate PYQs. Okay, all the gate PYQs we will be seeing, especially the all the ones which are little even a little trickier. Okay, if the PYQ is even a little trickier, then we will be seeing that PYQ. Now, one more thing that I want to address is that in this particular topic, okay, from this particular topic, I can say that Gate has asked, many questions. So among those questions, most of the questions are aptitude based. Okay, so most of those questions are aptitude based. What do I mean by that? Not numerical aptitude, not quantitative aptitude. I mean that no, from here aptitude I mean just general aptitude in the sense that they ask like few things related to stack and queue where you do not need to know the concept of any implementation of a stack and queue. You just need to know that okay, stack works like this, that you push and pop from the top, right? Queue is basically open from both the ended like this. Okay, so you just need to know this and then you need to solve that question. So the good thing is that if you are not able to solve some question, okay, some gate PYQ in this from this particular topic, that does not reflect anything about the strength of this topic. Okay, so which means that suppose you are not able to solve some PYQs of a stack. Okay, although we will be solving all of those PYQs, but I'm saying that suppose you are not able to solve some PYQ of a stack, then it doesn't mean you do not know stack. Basically, it is all about the aptitude, and it may or may not click in the examination. Okay, so don't worry, let's just see the questions. Okay, let's just see the questions. So let's see this question. This question has been asked in gate 1994, and let's just see what this question is saying. So they are saying a queue containing n items, okay, and an empty stack S is given. So basically a queue is containing n items. You can say 1 2 3 4 something like this, okay, like n items, and there's an empty stack. It is required to transfer all the elements from queue to stack so that the front of the queue. So see the notation wise, always remember this is the front. Okay, this is always the front, and this is always the back. This is just like very easy how you can remember that what is the front and what is the back of the queue. This is very easy to remember. I mean, you can just think in terms of the general example where you have the queue. So suppose you are standing in a line. Okay, so suppose this is some person, this is some person, this is some counter. Okay, so suppose there is some counter. Okay, that is there, and there is some person standing here. Okay, and then if three persons are coming are at this counter. Okay, and this counter maybe anything, maybe ticket counter or maybe some other counter. Okay, something like this, right? So if three persons are like this, then obviously this person is at the front. Okay, this person is at the front, right? This person is at the back, or we also call it rear. Okay, so this person is the front and this person is at the back, or we also call it rear. So basically you can say whatever whoever has inserted first, actually this is on the front, right? Whoever got inserted first, that is on the front. So just I'm just telling you the general terminology that this is called front. Okay, this is called front. This we will be calling front. This we will be calling rear. So they want to transfer all of these elements here. But the thing is that if you are having a queue, then you have to first deque one, and then one will get shifted, right? So this will be 1 2 3 4. You will be shifting like this. But they don't want like this. They want that one should be on the top. They are saying that front, whatever is the front. Okay, so they are saying that front of the queue. This is important line. Front of the queue is on the top of the stack. Okay, that's what they are saying. So what you can do, let's just solve this quickly. See, if you directly insert, then obviously it will not be the front will not be on the top, which means that if you directly insert these four items into the stack, then you will be dequeuing it. you will be putting it here, so one will be here, right? So basically at most what you can do, at most what you can do, you can transfer, that's not an issue, but one will be on, not on the top. So once you transfer, you will be having something like this, right? Something like this, you can say that one will be here, then two, then three, then four, right? Okay, you can say something like this. Now, if you put them again back to the queue, interestingly, if you put them again back to the queue, then what will happen? In that case, it will look like this. See, if you put all of these items back to the queue, then 4 will be on the top. So that's why 4 will get inserted first, and then 3, then 2, then 1. Now from this queue, you can put in the stack, right? Now from this queue, you can put in the stack, and then it will be 1, 2, 3, 4 in your desired order, which means queue will be just empty. There will be nothing in the queue. And then stack will be having, first of all, 4, and then in the same order, right? 4, 3, 2, 1. So basically, if you want to transfer all the elements of the queue to the stack such that one is here on the front, it should be on the top, and all the elements should be following the relative order. In that case, you have to first transfer all the elements of queue to the stack, right? And then from stack to the queue again, and then from queue to the stack again. So basically, something like this. Okay, move all the items queue to stack, stack to queue, and then queue to stack, right? That's very easy, just a simple observation. Using a simple observation, you can do it. Okay, so I hope that is fine to everyone, right? How to do it. Now let's see a next question, which has been asked in gate 2001. So what they are saying, what are the minimum number of stacks are required to implement a queue of size n? So let's just see this question, that what is the minimum number of size stack of size n are required. So basically they want to implement a queue using a stack. Okay, so they want to implement a queue using stack. So how many stacks are required? Probably you know this, that we need two stacks, right? So we need two stacks, something like this. Okay, suppose this whole block black box should be working as a queue. So in that case, if you're inserting one first, okay, if you're inserting one first, then one should get popped out only, right? I mean, if you're inserting in this order, one, two, three, okay, then output also one first, and then two, and then three, right? Something like this, right? So that's what you want. Now, what we need to do here, you might remember this from the lectures, that we will be using, let's just call it stack 1, let's just call it stack 2. We will be using one of the stack for NQ and another stack for DQ. Okay. How? If you want to NQ, you can directly NQ. See, suppose you want to NQ, then you can directly NQ 1, 2, 3. But if you want to DQ, in that case, you will be first transferring all the elements to this stack, and then you will DQ. That's all, right? I mean, if that stack is not empty, if that stack is empty, you just transfer all the elements. That's the only, extra step. So basically, NQ is easy. For the NQ, it is same as push to S1. That's all. Okay. But for DQ, you just need to take care that you need to pop from S2. That's for sure. Okay, pop from S2. I mean, that is correct. This is correct. You need to pop from S2. But just a little bit one extra condition that you have to write. Okay, before popping. What if stack S2 is empty? In case S2 is empty, you just transfer all the elements from S1 to S2. So, for example, see, you might see this slide. Okay, so this is the kind of pseudocode I have written. So here I am saying that push to, I mean, this is very easy. You can directly push. There is no modification. Nothing is needed here, right? But if you want to DQ, if S2 is empty, okay, then move the elements from S1 to S2. Otherwise, you can directly pop. Okay, otherwise you can directly pop. That's also very easy. I hope you understood, right? So if you transfer all the elements, then it will be basically 3, then 2, then 1, and then you can pop. Okay, if you pop, then 1 will get popped first, then 2, then 3, right? So if S2 is already having some element, then you can directly pop. But if S2 is empty, then transfer all the elements. Okay, that's the only little bit of modification that is required to do, right? Okay, so I hope that is fine. Now let's see this question. This is not a directly gate PYQ, but I have basically taken this question Okay, I just want to solve this question before solving one of the gate PYQ. This is, I can say, this is not a gate PYQ. Okay, not directly a gate PYQ, but some this will help us to solve one gate PYQ. So in this particular session we will be solving gate PYQs only. So but this is not a gate previous year question. PYQ means previous year question, right? This is not a gate PYQ, but still we are going to solve this. Okay, let's just see what this question is saying. So they are saying that you have two stacks, okay, S1, S2, and you want to implement a queue, just like I have just shown you, right? I mean, if you want to NQ, you can directly push. If you want to DQ, then directly pop, that's not an issue. But before popping, you can just check if a stack is empty, then basically transfer all the elements. That's all, okay? Transfer all the elements. I mean, this basically, what I'm saying, this NQ DQ is same as what I have just shown to you. Okay, it is just that I'm writing this in the code format, C code or something like this. But this is the same as same DQ that I have just shown you, right? The following sequence of operations is performed on an initial empty queue. So basically, you're NQing, DQ, NQ, DQ. So if you notice, there are three NQ, one, two, three NQ, and two DQ only. I mean, that's fine. I mean, that's not an issue. But let's just see what they are saying. Okay. So they are saying let X be the number of push operations and Y be the number of pop operations. Determine X and Y. So basically, what they are saying, let me just tell you. They're asking number of push and pop. See, we are doing NQ and DQ, but this is getting implemented using stack. So let's just see this, that how to do it, right? So as we know, we have two stacks, S1 and S2. Now you are going to push 10, and then you are going to DQ. So basically, let me write number of push operations. So X is number of push operations, right? So one push you have already done, right? For this, so one you can count one plus, and Y is basically number of pop operations. They are asking number of push and number of pop operations. Okay. So one push you have already done for 10, right? Plus, then you are DQing. So this is a pop, right? This is a pop. So you will pop it. Now, push. So one more. Now you are again DQing. So basically pop it, right? Sorry, for the as per the code. Okay, let's just go as per the code. So basically code is saying that you are going to pop from S2 only. So basically you do this NQ, which is fine. Now whenever you're doing DQ, you have to pop from S2 only, right? So since S2 is empty, you just first have to transfer all the elements. So you just pop it and push it to S2, right? And then again pop. So basically two pop, right? One from here, one from here, because you need to pop it, push it here, then again pop. So two pop because of 10, and 10 is again going to be pushed here into S2. So that's why two push because of 10, right? Two push because of 10. Okay. So two push. So basically, I think this NQDQ is fine. Now, similarly, for this NQDQ, for this NQDQ setup, 2 plus 2 will be here also. Now you are NQing 30. Basically, now it is empty. Now you are NQing 30. So just for the NQ, you need to push it, right? So 5 is here and 4 is here. Okay. So 5 are the number of push operations and 4 are the number of pop operations. Is this fine to everyone? Let me know. Okay. That's easy. You just need to follow the code. Okay, whatever code is given to you. So basically in this code, if I write this code as a pseudo code, then they are saying just transfer all the elements from S1 to S2 and then pop it. Okay. Now let's see the similar type of question. Okay, here they are basically having the same question, just changing the sequence of operations. So basically earlier they were having alternate NQ DQ NQ DQ. Now they are having three NQs first and then two DQs at the end. So let's just see. There are two stacks using which we are actually implementing this queue. Okay. So if you NQ, let me write X number of push operations. Let me write Y number of pop operations. Okay. So this X is number of push operations. So basically, if you have NQ, you will be pushing. If you have NQ2, you will be pushing. If you have NQ3, you will be pushing. So three push operations till now. Now for the DQ, you have to basically, if you are doing two DQ, so basically first you have to transfer all the elements, right? So three more push, sorry, three pop and then three push, right? So three pop and then three push, right? Then all the elements from here you will be basically shifting to here, three, then two, then one, right? So I hope that's fine. And now you will be basically dequeuing, right? Now for the deque, there is one more pop. Now you will be dequeuing once again. There is one more pop, right? So basically there are six here and four and five here, right? So six and five is the answer here. Six and five. Is this understood to everyone? They're just asking number of push and pop operations, and you just need to follow the code. Okay. If you follow the code, then you can basically do it. Now suppose in the same question they have 10 NQ. Suppose. Okay. So NQ, basically NQ 1, 2, 3 till 10 and just one DQ. Then can you tell me number of push and pop operations? Okay. So 1, 2, 3, you have to push all this 10. So X is basically 10 already and Y is, now the moment you do DQ, there is 10 pop, 10 push, right? Then all the transfer, all the elements will be here and then one more pop, right? One more pop. And which element will get popped? Can you tell me? If you transfer all of elements from here to here and then pop it. So one, okay. So one will get popped, right? Now just assume that if I just, just change the sequence of operation and I just basically insert this, I just write this DQ after this NQ. Suppose I just write this DQ after the NQ. Okay. Which means, let me just tell you from the beginning that what is happening. Okay. Which means I push one. Okay. So number of push, I NQ one, number of push is basically one. And then I DQ it. Okay. I immediately DQ it. So this is DQ operation. Okay. I immediately DQ it. So if I DQ it, it will be just a pop, push. Okay. Pop from here and then push. So one pop, one push, and then actually it is popping, right? And then all of these elements are just NQ. So NQ means just push, right? So which means nine more pushes. So basically, if you just transfer this DQ from here to here, then this is coming out to be 11. This is 2. Earlier, this is 20 and this is 11, right? See, now it is just 2. Number of pop operations is just 2. See, what is happening? Just to DQ1, okay? Earlier, just to DQ1, I have to unnecessarily transfer all of these elements from here to here. And then only I can DQ. But what if I DQ immediately? Then there is no unnecessary transfer of anything, right? There is no unnecessary transfer of anything. Is this fine to everyone? If I DQ immediately, then there is no unnecessary transfer of anything. For example, if I DQ immediately, then one, because of one, no one is getting unnecessarily transferred. Okay. So I hope, this question was easy, but I'm just trying to analyze, make some little more analysis. So the analysis that I'm coming up with this, something like this, that if we have these two stacks, okay, and because of this two stacks, you are basically implementing some queue using these two stacks. And then if we are pushing one or enqueuing one, right? After that, if you immediately dequeue it, then because of this one, there is no unnecessarily pop, right? Unnecessarily pop. But suppose if you push all these elements and then you say that okay dequeue, then dequeue means you have to basically remove this one. Then you have to first transfer all of these and then like this, right? So number of I can say operations, push or pop operations can be reduced if immediately I'm dequeuing, right? NQ, then DQ. If immediately I'm dequeuing, then number of push and pop will be reduced. But if I'm dequeuing at the end, then number of push and pop operations will be maximum. Basically, what I mean to say, if I NQ all the elements first, okay, and DQ all or DQ whatever. Let's suppose I'm NQ 10, DQing just two elements, it is fine. If I'm DQing all the elements later, at that point in time, I'm basically making the maximum number of operations. If I'm DQing all the DQs at the end, but if all the DQs immediately after NQ, then I'm basically having minimum number of push and pop. So what I'm trying to say, see, we can solve this question. The next question is basically based on this concept only. That's why I told you. See what they are saying. The same question only. They are saying that suppose there are 10 NQ operations, okay, that you want to do, and M DQ operations that you want to do. So basically, it could be 10. So maybe 10 NQ, just 2 DQ you want to do, right? Are performed, determine the sequence that will result in the minimum number of push and pop. Okay. So they're saying you have two stacks using which sequence there will be minimum number of push and pop. Okay. See, suppose you are NQing 10 operation, 10, okay, NQ1, NQ2. So you can immediately DQ, or maybe you can DQ after two elements, okay, DQ, and then NQ3, then NQ4, then NQ5, and then DQ, right? And then NQ6 until 10, right? Suppose. So you are NQing, so two shift you have done. Now to DQ, you have to basically transfer all of these elements, and then this will be two, this will be one, and then this one will get popped out, right? So that's how you're duking. So basically, two got unnecessarily transferred, right? Now, NQ this 3, 4, 5. And now here the benefit is that see, I mean that two got unnecessarily transferred, that I agree, but this is actually here it is not a problem, because now the moment you DQ it is already there, right? But suppose you have just one more DQ at the end. I mean, once this is empty, okay, once this stack is empty, now you have one more DQ at the end. Now just to DQ, and you have already pushed 10 elements, so now just to DQ this 3, right, you have to transfer all the elements. That's the problem, right? So basically, if you are leaving, you can say, if you are leaving this S2 occupied, which means if you are not emptying, if you are not having enough DQ, using which S2 is basically empty, then there is unnecessary transfer. Okay, so basically you should be transferring the elements to S2 which you want to DQ. If that is the case, then you are having minimum number of DQ. You getting my point? So what I'm trying to say, that you should transfer to S2 only when it will be DQ'd. That is S2 empty at the end. Then it's not a problem. In that case, it is a minimum number of operations you are doing, no unnecessary transfer. Okay. So in that case, there is no unnecessary transfer. No. Okay. In that case, there is no unnecessary transfer. I hope you got the point, right? See, if you're transferring the elements which will eventually be DQing, right, then in that case there is no unnecessary transfer, and then it is a minimum number of operations. Okay. So you can say, see, there are multiple valid sequence, but that is one sequence which is for sure will lead to minimum number of operations is something like this. Okay. One sequence that will for sure lead to minimum number of push and pop operations is something like this. Okay. NQ, and let's suppose there are 10 NQ and just 2 DQ. Okay. So if there are 2 DQ, then you DQ immediately. Okay. Then NQ and then DQ immediately. So NQ2 and then DQ immediately, right? And then you can have, let's suppose just want to have 2 DQ, and then you can have any number of NQ in the future. Okay. For example, NQ3, NQ4, okay, NQ10. Understood? Is this fine to everyone? So basically, this will lead to the minimum number of operations, because you are not unnecessarily transferring the elements. See, this will also lead. I'm not saying this is the unique sequence. Okay, this will also lead. For example, NQ2, and here since you have two DQ. Okay, so all the DQ immediately after the NQs. Okay, so DQ and DQ. Okay, and then NQ3. Okay, this will also basically lead to NQ4 minimum number. This will also, because the number of NQs, okay, in the prefix are not more than number of DQs. So if you want to do two DQs, then before the two DQs there has to be only two NQs. Okay, I mean, if there are little, if there is one more NQ, then basically this is unnecessary transfer. So this will also lead to minimum. Okay, I'm not saying the above one is only minimum. This is also minimum. This is also minimum. But just for the simplicity, you can understand that immediately DQ is a minimum. Okay, they can even ask a question as a homework. You can take this question, that how many if you want to have 10 NQ and 2 DQ, then how many particular combinations of permutations and combinations will lead to the minimum number of push and pop operations. There you need to obviously make sure that DQ, okay, I mean, this is basically kind of balance parenthesis. You can just assume like balance parenthesis kind of problem. So basically it is like for every NQ there is a DQ, okay, something like this, right? So basically what I'm trying to say, there you need to basically check all the sequences which will lead to the minimum, and you need to make sure that if you are having 2 DQ, or let's suppose if you are having 3 DQ, then you can have DQs anywhere. These are the 3 DQs. Okay, you can have DQs anywhere. But before 3 DQs, okay, this before this last DQ, you can say that at most there has to be 3 NQs only. Okay, at most. I mean, exact, not at most, exactly. There should not be. I mean, there cannot be even lesser. There can be more only, but you want exactly, right? So exactly 3 NQs. Right? If there are exactly 3 NQs before the before the third DQ, then there is a minimum number of push and pop operations, right? Because you are not unnecessarily transferring. Whatever you are transferring to S2 ultimately get DQ'd. Okay, that will ultimately get DQ'd. Understood? So basically, there are like many combinations, and you can easily solve this question, I think, right? So maybe I can just tell you NQ 1, 2, 3, right? So basically, uh, so 3 NQ, 2, so 5 factorial divided by NQ. So I think 3 factorial for the NQ 1, 2, 3, because you cannot permute those NQ 1, 2, 3. And then I think this is also, I think, 2 factorial, because these are the identical. And DQ cannot come at the first, right? So we need to take care of that also. So basically, this is a combinatorics problem. I think you can solve this. I'm leaving it here because it is not related to stack and queue. Okay, we can solve this question. It's not a very tough question, but I hope you got the point, right? So basically, exactly 3 NQs should be there, right? Exactly 3 NQs should be there. So this will lead to the minimum number of problem. Now suppose minimum number of push and pops. Now suppose there are more NQ. Okay, and there are more NQ, let's suppose 4 and 5, then actually it is not the optimal case. It will lead to the unnecessary transfer. Okay, of all the let's suppose there are 5 NQs. Okay, NQ 1, 2, 3, 4, 5, 5 NQ in some order. Then 4 and 5 are getting unnecessary transfer to S2. Okay, so basically, if you are having 4 and 5 here, okay, 4, 5 somewhere here, right? So these are, you can say, these are getting unnecessary transfer to S2, which is not good, right? Okay. So if there are, like, you can say, if there are an NQ operation and M DQ operation you want to do, right? Obviously, M is less than equal to N. Obviously, that's very obvious, right? So what is the minimum number of push and pop? So basically, you can say that here I have, let's suppose this is NQ, okay, and now whatever DQ I want to have, so basically you can just immediately DQ, right? NQ DQ. Let's suppose, just for the sake of simplicity, right? NQ DQ. So let's suppose these are the N pairs of NQ DQ, right? And then remaining NQs are here, right? Remaining NQs. So can you tell me number of push and pop operations? See, because of one pair, you will be basically first pushing, right? First pushing here, and then one push, then you are popping one pop, then one push here, then one pop. So two, right? Two because of one pair you can say it is two, right? And because of m pairs it will be 2m. Is this fine to everyone? So if you are basically NQing, so if you ask me, there is one push here, then you are going to pop, and then there is that popped element will be here, one push, and then you are going to pop, right? So you can say there will be two, right? Two push and two pop, right? Or in other words, you can say for every, yeah. So basically for this DQ, okay. So for this every NQ there is one push, one pop, one push, one pop. I mean, basically, I'm counting two in the sense that there is basically m. If there are like m DQ that I want to have, so there will be how many pushes? You can say for every NQ there is anywhere push, right? And then okay, see, let me just go to the next page. I want to say this is one NQ, this is DQ, NQ, DQ, right? Like that you are having. Now they're asking number of push and number of pops. Okay. And then remaining NQs are here. For the because of remaining NQ, okay, or you can say in other words, to be very simple, for every NQ there is just one push, right? So for every NQ there is anyway just one push to S1. Yes, for every NQ, because of NQ there is just one push, right? Because of DQ, because of DQ, there is also one push and only one push. See, because of DQ, you are just going to pop it out and then you are going to push it here. For because of every DQ, there is only one push. Because of every NQ, there is one push. Because of every DQ, since you are not unnecessarily transferring, so that is why because of every DQ, you can say there is just one push. Okay, just one push. What about pops? Because of every NQ, there is obviously no pop, right? But because of DQs, okay, there is one pop from here and then there is a one pop from here, right? So because of DQ, there will be 2m pops. Is this understood to everyone? Okay, you are going to pop from here and then you will push it, then you're going to pop from here. Because of NQ, there is no pop. So because of NQ, there is a push, right? There is a push, so N push. Uh, and because of DQ, how many pushes are here? You are going to push only M elements because M DQs, so only M elements. That's important, okay? That's important. So M DQ, so only M elements you are going to push, right? So I mean, basically the concept here is that in the S2 we want to push all the elements which eventually will DQ, which means if we want to DQ M elements, then M only pushes, okay, will be here to S2. Understood? And what about the pop? Pop basically all the M elements from here will get popped. All the M elements here will get popped. So two M elements. So N plus M and 2M. Okay. What could be the maximum, by the way? So what could be the maximum X and Y? Which means number of push and number of pop. Can you tell me? Number of push and number of pop. So basically here the idea is that in the S2 we want to transfer maximum unnecessary, which means that we want to basically push all the elements. Anyway we have to push to S1, so n elements and n elements I will be pushing here in S2 also. See, earlier in the S2, I will be pushing m elements. Whatever is required, I was pushing there. But here, I will be pushing all the unnecessary elements. I mean, all the elements I will be pushing. I want to see the sequence exactly doesn't matter. I will tell you the sequence, but I will make the sequence such that all the n elements are here. Okay, all the n elements are here. This is my idea. I will make the sequence such that all the n elements are here, right? Right. And what is the number of pop operations? So basically, the thing here is that my sequence should be such that all the pushes should be here, and all of those should be transferred here, and then all the pop should be here. So number of pop. So first you are popping from here, and then you will be popping from here. But from here you can pop only m. From here you can pop n. So this is n plus m. Okay. So 2n and n plus n. So if they ask you, let's suppose the maximum. Okay. So this is the next question where I was actually asking the maximum. If they ask you the maximum, then it is 2n and n plus n. Is this fine to everyone? So with this, now let's just go to the gate PYQ and let's just solve this. So this PYQ has been asked in gate 2006. Okay. In gate 2006, this PYQ has been asked, and this is a very nice PYQ. Okay. So they are giving you some code. The code is basically the same, exactly same that I have already shown you. Now just solve this PYQ just like you are seeing this very first time. Okay. Let's just solve this PYQ just like we are seeing this very first time. I mean, obviously we are seeing this very first time, but don't worry about the earlier discussions. Okay, they're asking they're asking the same thing: the minimum number of push and minimum number and the I mean they're asking the all the things: minimum and maximum pushes and minimum and maximum pops. So minimum and maximum, they're asking number of push x, number of pop, number of push, number of pop. See, sequence doesn't matter. Okay, sequence could be anything, but I want to make sure that how it could be minimum and how it could be maximum. See, I want to make sure for the minimum, S2 should be having S2 should be having only M elements in its lifetime, right? Lifetime means like in this whole program, not more than M elements should be pushed here, right? See, if you are pushing N or NQN, okay, and M or DQ, right? So because you are having n and q, so n anyway you are going to push to here, right? Now sequence doesn't matter. Don't worry about the sequence. But we are eventually popping out only m elements from here. So pop only m elements, then pushing those eventually m elements here, pushing those eventually m elements here, and then popping those m elements, right? So this is the minimum that you will be doing. What is the maximum that you will be doing? For the maximum, you can say you are pushing all the elements anyway here, right? Now you will be transferring all the elements from here to here, right? So popping n elements, earlier it was m, remember, earlier it was m, right? Now from here to here, they are popping and then pushing all the n elements, right? All the elements, n elements you're pushing. But for the pop, you're only, obviously, you have to only pop m elements, okay? This will be m. Is this understood to everyone? Let me know. Okay. So this is n plus m and this is 2m. This is 2n and this is n plus m. This is very interesting question, isn't it? See, this question could be hard at the first place, but once you understand the logic behind it, okay, what is the core concept of this question? For the minimum, you will be transferring only m elements. For the maximum, you will be transferring total all the elements from here to here. Okay, then only you can achieve the maximum, and for the minimum, you will be transferring m elements. Okay, with this, you can solve this question very easily. Let me know if that is understood. Okay. So minimum is, you can say, now you can say x is basically x minimum. It is basically n plus m. Maximum it is 2n. For the y, you can say minimum 2m and maximum it can go till n plus m. Okay. So x should be less than equal to n plus m. and 2n, y is 2m, and a plus. I think A is the answer, right? A is the answer. Let's just check the answer. Yes, A is the answer. The order in which perform measures, insert and delete operation are performed alternatively in every. So basically, the this is not only the best case. Tell me, is this the best? Is this the only best case? If they perform alternatively, is this the only best case, or there are other best cases also? Tell me. There are definitely other best cases also, right? You just need to make sure that all the elements of S2 should be not more than 5m. Okay, not it. I mean, only whatever you want to DQ should be transferred into S2. So you can say this is not only the best sequence. There are multiple best sequences. In fact, there could be question that how many best sequences, right? There are multiple best sequences. Okay. Similarly, there are multiple worst sequences. Okay. See, for the worst, okay, for the worst, one DQ should be at the last. As long as one DQ at the last, after this DQ, there is no NQ, it is the worst, isn't it? I mean, if one DQ, okay, at least one DQ at the last, okay, this DQ is at the last, and before that, whatever you do, it actually doesn't matter. If one DQ at the last, this is the worst case. Okay, this is the last operation should be DQ. DQ, then it is worst case. Why? Because it will force. No, sorry, I cannot say like this. Because maybe S2 is not empty, right? Okay, I cannot say like this because maybe S2 is not empty. See, I just want to force all the elements transfer, right? So, okay, so we need to analyze a little more carefully. Yes, I cannot say like this because I need to transfer all the elements and I have to check if the S2 is empty or not, right? I actually have to transfer all the elements. That is the worst case. But there are multiple worst cases possible. Okay, there are multiple worst cases possible. So in the test papers, I will be making some variation of this question because this question is very nice. Okay, I will be making some variations of this question for sure. Now let's see this question. This question has been asked in GATE 2016. But before that, if you have understood everything about the question that I'm currently explaining, then just let me know. Okay, and if there is any issue, then also you can just let me know. Okay, great. Now let's just solve this question. A queue is implemented using an array such that NQ and DQ operations are performed efficiently. Which one of the following statement is correct? N refers to the number of items in the queue. Both operations can be performed in order of one. So they are saying that queue is implemented using an array. Okay, and then you want to do NQ and DQ. So basically, this is an easy question. Okay, basically, what you can do, you can have an array, and then you can very easily in order of one, you can do both NQ and DQ. If you want to see, front is basically like this. Okay, if you want to DQ, you always do from front. Okay, so if you want to DQ, you can just basically increment this pointer. Okay, and if you want to NQ, then also you can increment this pointer. Basically, increment both the pointers in the same direction. Okay, NQ, DQ both will increment the pointer. If you want to DQ, then you can increment this pointer, and then you can say, okay, return this. Okay, if you want to NQ, then you can just basically insert something here and increment the pointer, something like this, right? Increment both pointers in the same direction, right? NQ means like just put that element to the rear, and DQ means return that element from the front, and then you can increment the pointer. For the increment, I'm actually implementation is not important here, but for the increment, I'm using the mod. Mod means like whenever I want to increment in the wraparound fashion, in the sense that if it is at the last, then I will basically incrementing. Okay, using the mod operation. Okay, so that it doesn't go beyond the array. Okay, great. Now let's solve this question. So basically, by the way, for this question, both operations can be done in order of one time. Okay. Now let's solve this question. Again, this question is not directly related, directly a gate PYQ, but it is related to a gate PYQ. Okay. So what this question is saying, consider a queue where this is at the front and this is at the back, which means here you need to deque. Front means you will be dequeuing from here. Okay, so don't by heart it. You can always imagine that okay, q front means this, and you are going to deque, right? After the first two iterations of the algorithm, what is the content of q and s? So basically, they are saying this is some algorithm that is given to you after first two iterations, right? So what this algorithm is saying, let's just first try to see this. I think yes, the same pseudocode I'm writing it as a simplified version on the next page. So basically, some pseudocode is given to me, but what we can do, we can write the same pseudocode as some simplified version. If S is empty, so basically what they're saying, if S is empty or some top of a stack is less than equal to front or head, then DQ and push. So DQ push. So basically, let's just see this algorithm. Okay, so both are the same. I'm just removing one of this, and Q is initially containing 3 to 1, and they just want to have two iterations. So basically, this is the Q which is containing 3 to 1. See, if a stack is empty, then okay, let's not worry about it. So basically, if a stack is empty, then obviously DQ, okay, DQ and push it. Okay, if a stack is empty, then DQ and push it, right? So initially, since the stack is empty, you anyway have to DQ and push it, right? Now, if a stack is not empty, then we will see something. Then if top of the stack is lesser element, okay, since it is not lesser, so if it is greater element, you will be basically uh, you will be popping it and then pushing it, right? Pop and push. See, in one iteration, you are basically transferring this 3 to here. And then in another iteration, right? And there is a two iterations that you want to do. In another iteration, you are seeing that, okay, this 3 is greater than the 2. Okay, so this 3 is greater. So basically, you are going to pop and then NQ. So basically, if so you don't want greater elements in the stack. Okay, if the greater element here, okay, in the queue, sorry, in the stack, then you just transfer it. So basically, now you have as a queue, you have 2, 1, 3. Okay. So you have 2, 1, 3. So what is the answer? C is the answer. Is this clear to everyone? See, that's very easy algorithm that they have given. I'm just basically trying to run this, right? So let me write this algorithm on the next page. So basically, they are saying initially you are having 3, 2, 1, and stack is empty, right? And stack is empty. Now, now Now, because of this one iteration, since the stack is empty, you don't have to worry about any other condition. You just deque and push to the stack. Okay. So after one iteration, you will be having 2, 1, and stack will be having 3. Right. Okay. Now it is anyway having 3. And then if this element is greater, see stack, see based on the algorithm, this is they are saying that stack should not be having the greater element. If this element is greater, then you just pop it and then push it to the queue. Okay. So you push it to the queue, so it will be empty anyway. Right. So this is one iteration. This is second iteration. Okay. So 3 to 1 is the answer. The queue will be having 3 to 1. And stack is basically ultimately, in this particular case, it is empty. But now let's just see what happens if I keep on continuing this algorithm. Okay. If what happens if I keep on continuing this algorithm. Now what will happen? Let's just check. See, now since the stack is empty, you will anyway push. So you will push this 2, right? Now you will compare. Since it is greater, you will again transfer here, right? Since it is greater, remember, since 2 is greater than 1, whatever is the greater element, you are going to transfer to the queue. Now, ultimately, you got, since the stack is empty, you are anyway going to push this one. Now, ultimately, you got 1, right? And 1 is not greater than anything, right? If it is lesser, right? If it is lesser, then you can deque, then you can deque and push it. Okay. See, 1 is not greater. So basically, now no one can replace this one. So based on the code, let me tell you, this code is trying to trying to store elements in stack in increasing order from bottom to top. Let me tell you how. Okay, let me tell you how. See, suppose, let me just tell you, some random order is there. Okay, suppose this is 4, then 5, then maybe 2, then 1, then 3. Okay, suppose this random order is there. Okay, now there is a stack. Now just see what it is doing. Okay, let me just go to the next page and let's just try to see that what it is doing. See, since the stack is empty, you don't have to worry. You just push it here. Now, whatever, see, if it is lesser element, you will keep it. You compare 5 and 4. Since it is lesser element, you will keep it as it is, and then you will deque. You will deque only when here it is lesser element. The aim is that you have to have lesser than greater. I mean, it is should be in the increasing order. So currently it is it is in increasing order. It is very good, right? Now 2 comes. 2 will basically pop out everything because 2 is smaller than everything. So 2 will pop out this 5, right? 5 will be here. 2 will pop out this 4. 4 will be here. And now 2, since the stack is empty, so 2 will go and sit here, right? So 2 will go and sit here. Now 1 is coming, right? Now 1 is coming. Now 1 will pop out everything because 1 is smaller than everything. So 1 will pop out this 2, and ultimately stack is empty, so one will sit and sit here, right? So 3 5 4 2 are there and one is here. See, basically once one is here, okay, once one is here, then one can I mean no one can basically pop out this one. Why? Because this is the minimum element. Or in other words, you can say, in other words, let's suppose stack is currently containing 3 5, okay, 4 10 7, anything, okay. The moment, let's suppose this is the queue, this is having 1 1 9 7, okay, 6, something like this, right? The moment one is coming, it will pop out everything, and one will sit here. Okay, the moment one is coming, it will pop out everything and it will sit it here. So basically the minimum element will sit here, right? And then obviously no one can pop out this one, right? So one is permanently, you can say, fixed. Okay, it is fixed. Now, using the recursion, or I can say induction, or whatever name you want to say, okay, using the loop invariant or whatever you want to say, okay. So you just tell me that what is the next element which will be fixed here, that no one can basically pop out it. What is the next element which will get fixed? Can you tell me? See, once one is coming, it will be fixed here. Fixed means you are cemented. Okay, no one can pop it out. So what is the next element which will be cemented? See, it is all about, elements are all about relative. If one is not there, what is the next minimum that you have? Okay, suppose these are the numbers from 1 to 10. Okay, so 2 is the next minimum. If these are the numbers from 1 to 10, then 2, once 2 come, it will be cemented, isn't it? So the thing here is that, in the stack, okay, once one come, it will pop out everything, and once one will be here and it will be cemented. Okay, it is fixed now, right? Is this fine to everyone? Now 3 can come, 4 can come, whatever can come. Now once this 2 is coming here, it will pop out everything and 2 will be cemented. Again, this 2 will be cemented. Once this 2 is coming, this 2 will be cemented. Is this fine? Let me know. Is this fine to everyone? Now, similarly, in between, now 5 can come, or 6 can come, anything can come. But once this 3 is coming, it will pop out everything, and then no one can pop out this 3, right? It will pop out everything and no one can pop out this 3. 3 will be cemented, you can say. Okay. So that's what this algo is doing. This algo is making sure that that number of, I mean, all the elements here will be basically in the increasing order. This algo is actually making sure something like this. Okay, so this algo might look complex, but ultimately this is making sure that stack is containing all the elements in the increasing order. Okay, so let's just do one thing. Let's just solve this question, which is similar to the earlier question. Okay, let's just try to solve this question. So they are saying first four iteration you want to run, and this is 8 5 7 6 you have. Okay, so you are having 8 5 7 6, and this stack is empty. Okay, so number of iterations actually doesn't matter, but yeah, let's just have only four iterations. So in one iteration you will shift 8. In the second iteration you will compare these two. Since it is greater, it will get popped out, and second using the second iteration, ultimately it is here. In the third iteration, since this is empty, this 5 will get be here. I mean 5 will be here. In the fourth iteration, since 5 is only you can say minimum, I mean among these two 5 is the lesser element, so 5 will not get popped out, and 7 will be shifting. So basically q will be containing 6 and 8, and stack will be containing 5 and 7. Okay, so this will be the answer. Q will be containing stack will be containing 5 and 7. So I think, and q will be containing 6 and 8. So I think here uh, actually the option I just made this question. So let me just first again try to rerun again. Maybe there is some mistake in rerun, or maybe some mistake in options. Let's just quickly verify. So 8576 is the order, right? 8576. Okay, so let's just quickly verify. It's easy question only. But I hope, see, the purpose of making these questions is just to make sure that you understand this algo, what this algo is doing, right? So this is 8576. Now in the first iteration, 8 will be shifted here because stack is empty. In the next iteration, since you compare 8 and 5, whatever is the minimum, it will be shifted. I mean, minimum should be in the stack. Since 8 is greater, so it will be shifted here. In the second iteration is done. In the third iteration, 5 will be shifted here. In the fourth iteration, and since it is minimum only, so 7 will be shifted, right? So yes, so Q will be containing 6 8, and stack will be containing 5 7. So you can say, maybe I can just make this option correct. Let me just modify the option. Okay, anyway, so I can say C is correct. Okay. Now, now let's see this question which they have asked in GATE. This is very interesting, and since this question has got 196 support, so it means that this question is quite tough. Again, let me just tell you, these all are aptitude kind of question. Okay, so this is also aptitude kind of question. I mean, there is no concept of a stack that you have to use here, no concept of queue you have to use here. It is just aptitude kind of question. And most probably most of the student might not able to solve this question in the exam because it is actually tough. But anyway, let's just see what they're asking, right? Okay, so all of this we already know. So they are saying the maximum possible number of iterations. So basically they are saying that you are having a queue is containing 16 numbers. Okay, 16 numbers they are containing, and then stack is initially empty, right? And then they are asking maximum possible number of iterations this while loop will be having. See, queue is containing 16 numbers, right? And stack is initially empty. So queue may contain 16 numbers in any order, maybe 2 here, 3 here, 5 here, right? Anything, right? And 1 here, 6 here, something like this, right? Again you tell me, if I want maximum number of iterations, okay, just like the previous question, it is also saying something like maximum. Then should I be supplying this one here at the first to the stack, and should I be supplying this one at the end? There is no midway. Okay, for the maximum and minimum kind of question, there is no midway. Just tell me, should I be supplying this one here so that it is getting fixed and now no one can remove this, or should I supply at the end so that when one come, okay, when one come, then it will basically remove whatever is in the stack, it will remove everything to the queue, and then one will get shift here. Should I be supplying at the first or at the end? I should be supplying at the end, right? Why? Because I want this one to basically pop out everything from here, and then I want this one to be basically then go and sit in the stack. So one thing is for sure that you can have in any order you can have. Okay, in any order you can have these numbers, these 16 numbers. Okay, so you can have in any order. I want to have one here. Is this fine to everyone? I want to have one here because I want to supply this one at the end. That is for sure. So basically after couple of iterations, okay. So I can say after couple of iterations, I actually want this one to be fixed. Okay, I mean this will automatically fix it. I mean I can't do anything here. Once the turn of one is coming, then one will get automatically be fixed, right? Is this fine to everyone? Now there is some garbage in the sense there is some order of elements which are here. Now again tell me, see at this particular position stack is anyway empty, right? Again tell me, I want to supply. Okay, 2 will actually pop out everything. I want to anyway supply 2 at the end, right? I want to supply 2 at the end, isn't it? Tell me, isn't it the case? Once one is fixed, I want to supply 2 at the end. Now again, right? So basically, I can say what if I have in this order? Suppose 16, okay, 15, 14. Since these are the 16 elements, 2, 1, right? This is stack empty. Now 16 is coming, okay. 16 is coming, and then 16 will get pushed here, and then because of this 15, 16 will get popped, and then 16 will be here, and 15 again the 15 will come, and then because of the 14, 15 will get popped or something like this, right? Will get popped, and then 15 will be here like this, right? And then the moment 2 is coming, okay, the moment 1 is coming, basically 2 will be at the top only, right? So basically if I supply like this, then this is 1, 16, 15, okay. So now, or in other words, you can say 2 has just popped out everything, right? Now the moment 2 is coming, 2 will go and shift here. 2 will go and shift here. Then 1 will actually pop out this 2 also. Okay. So basically, if I have in the reverse order, then automatically, the time 1 is fixed. At the time 1 is fixed, 2 will be automatically on the top. See, the thing here that I want to convey is that I want to supply 1 at the end, right? Is this fine to everyone? I hope this is fine to everyone, right? See, you can just have 4 elements or 3 elements, okay, for the sake of simplicity. Suppose you have 3 elements. See, 3, 2, 1. This 1 is getting supplied at the end, okay. Then 3 will come here, then it will get popped, then 2 will come here and 2 will get popped. So basically it will be anyway be reversed. I mean this 3, 2, they will be, I mean they will be going here and then they will be anyway coming here, right? So ultimately you will be having 1 at the fixed position, and then this is 3, 2. Okay, so this is actually a stack, this is a queue. Okay. So basically, if you are having in the reverse order, I mean to say, if you're having in the reverse order in the sense this is 16, 15, 14, and ultimately you are having 1, then let's not worry about the stack. Basically, you are going here and then again you are going here. So let's not get confused. For the sake of simplicity, you can say that the queue will look like this. Okay. Queue will look like this. This 16 will be here, then after 16, okay, 16 will be here, after 16, 15 will be here, then 14 will be here. I mean in the same order, it will maintain the same order, right? I mean if it is the same order earlier, then it is the same order now also, right? And then you can say if one has got popped out, so you can keep this one and two probably, but yes, so basically something like this, right? Something like this. So basically you will be popping from here, you will be pushing here, you will popping from here, and ultimately it will be Let's suppose 3 will also be get deque and get pushed to the stack only. So ultimately it will be something like this. It is fine to everyone. Now 2 will get also shifted like this, right? Now 1 will get disappear in the sense now there is no one. I mean, it is permanently to the stack. It is now permanently to the stack. So how many operations you are doing just to fix this one? I think you are basically uh, all the elements are going basically from here to here. How many operations you are doing? So what they are asking actually, they are asking number of iterations. Okay, so in one iteration, in one iteration you are shifting one element from here to here. So you're anyway basically you can say shifting 16 from here to here. So one iteration from here to here, and then one iteration from here to here, right? So since these are the 15 elements apart from this one, these are the 15 elements, so you are doing 30 operations, and then one is not getting shifted back. One is just basically you can say it is just one operation you are taking for the one. So 31 operations you are doing. After 31 operations your configuration will look like this. See, this is little typical question, okay, or little difficult question, but still I have taken this question. I hope you are getting little bit what I'm trying to say. You have to supply one at the end. That is the thing. And after 31 iterations, it will look something like this, right? Now, similarly, to fix this two, okay, to fix this two, since this was 15 into 2 plus 1, similarly it will be 14 into 2 plus 1. So, 14 into 2 is 28 plus 1, 29, right? So 31 plus 29 like this. Okay, there will be a series of AP 31, 29 plus something like this. Okay, if you add it up, it is 256. So the idea here is that you are going to 256 is the answer, which is the maximum number of operations they're asking. Okay, maximum number of operations that you have to do. Then what is that number? Okay, so basically you have to supply one at the end. Similarly, you have to supply once one is fixed, then you have to supply two at the end. And automatically, if you are having in this reverse order, then automatically you're supplying one at the end, right? And you're following the induction or recursion or like basically the symmetricity or the the intuition. You can say you can name it anything. So basically the thing here is that by symmetricity you can say that okay, if I want to supply one at the end, then one should be here, and then if I want to supply two at the end, then two should be here, which means it should be in the reverse order. Now once it is reverse and after 256 iterations, it will be okay, it will be 1 2 3 like this 16. Okay, something like this. Understood? So it is little typical question and more related to aptitude. Now let's just move to the next question. So what they are saying, a circular queue is implemented using a singly linked list, okay, using front and rear. Now they are saying the next pointer of the front points to the rear, okay, and the next pointer of the rear points to the front. So basically they are saying you are having a singly linked list. Suppose you can take anything as a rear, anything as a front. I'm calling this as a front. Okay, this is a rear. The idea here is that at the front, NQ should happen. Okay, at the rear, DQ should happen. Okay, so at the rear, at the rear, NQ should happen. At the front, DQ should happen. Okay, at the front, DQ should happen. So if you want to DQ, you can easily do it. Okay, but if you want to NQ, then also you can basically easily do it, right? I mean, at the rear DQ should NQ should happen, right? Now they're asking, should this front pointer be pointing next pointer pointing to rear? It doesn't make any sense. But yes, since it is a circular queue, you can point the rear pointer here. Okay, so you can definitely point the rear pointer, but the front pointer making point to the rear doesn't make any sense. So the rear can point here. So basically, if you want to NQ, you can say that that rear next equal to temp. I mean, you can basically have one here, and then this can point here, and rear you can shift, right? Then rear you can shift. Okay, I hope that is fine. And front pointing to rear doesn't make any sense. Is this fine to everyone? Okay. So here, from here, DQ should happen, and from here, NQ should happen. Okay. For NQ, you can do very easily. For DQ, you can just shift this pointer, and then you can ask basically this rear end, okay, to point to the front. I mean, whatever you have shifted, you can ask this point to the front. Okay. Now let's see this question. They are saying this is a head, this is a tail. The queue has a head pointer and a tail pointer. Now n is the number of nodes in the queue. Let nq be implemented by inserting a new node at the head. So basically, they are inserting at the head. I mean, the terminology here is that they are saying they want to insert here. Generally, it is good to remove. Okay, generally it is, as I have just told you, that it is good to remove and good to add here. But if you're if you're inserting here, okay, you can insert here also, not a problem. If you're inserting here and deleting or the deque is at the tail, then what is the time complexity? See, for the deque, the problem here is that you cannot deque. I mean, you cannot delete this node. I mean, you can delete this node using the tail pointer, but you can ask this node to point to null, right? You cannot ask this node to point to null or something. Basically, you have to have the pointer to the previous pointer, previous node. Then only you can delete it. Okay, then it is good to delete it, and then you can have the pointer making it to null. So basically you have to traverse to the second last, right? Which means if you want to insert, you can directly insert, it's not an issue. Okay, head will point here and that can do. So insert is very easy, you can do it in order of one. But for the deletion, you have to go to the second last using this. Basically tail is useless. Okay, this is useless pointer if you want to delete at the end. If you want to insert, okay, if you want to insert here, then it is a useful pointer. And if you want to delete it, then you can delete here easily. And if you want to insert here, it is a useful pointer. But if you want to delete for using this pointer, then it is useless pointer. You have to go till the second node. Okay. So B is the correct answer here. Now let's just see this question. What they are saying, that you have this 1, 2, 3, 4, and then uh, consider Q. Q1 is having the only operation allowed to these Q is NQ and DQ. So you can only do NQ and DQ. The minimum number of NQ operations that have to be done. So basically, initially it is containing. Let me just tell you what they are saying. Initially it is containing 1, 2, 3, 4. Okay, this Q is empty. Now you want to transfer all of the elements of this Q1. Okay, all of the elements of this q1, this is q1, this is q2, this is q1, this is q2, right? This one you want to transfer here, but they are saying you have to transfer in the reverse order, which means ultimately you want this. Ultimately you want this. First of all, is this possible to do it? Okay, let's just check. Ultimately you want this. See, you can do one here to here, and then two here to here, but it will be 1 2. I mean, it will not be 2 1. So if that is the case, then they are saying what is the minimum number of NQ operations that you should be doing to Q1. First of all, tell me, is this possible to do like this? I mean, ultimately it should be in the reverse order. That's what they are saying. Okay. The here the concept is that you can remove these two elements. See, I mean, there is no concept, by the way. This is just an aptitude question again. Okay, this is the final aim. So let me write the final aim at the end. You know the final aim, right? So let me write it here. See, the concept or the trick here is that you can remove these two elements. It will be exactly 1 2 like this, right? I mean, it will not be in the reverse fashion. But you can basically do one thing. You can pop it and then you can push it again, or you can DQ or NQ. But I'm just calling it pop and push. You can pop it and you can push it again, right? So basically, then it will be in the reverse order. So you remove these two. I'm not NQ anything to Q1. I'm basically removing and NQ and I'm basically doing the NQ operation to Q2 only. So you can remove this and then you can say, okay, let me push it again. So basically 3 4 will be here, and then 2 1 will be here. I mean, it is in the reverse order. Is this fine to everyone? Now you can transfer this 3 from here to here. That's fine. Okay, you can transfer. So basically it will be just containing 4, but here it is containing something like 1 2 3. Sorry, 1 2 and then 3. But you want in the reverse order. Basically you want this 3 here, right? You want 3 to 1. So how we can transfer this 3 such that, see, you want this 3 1 2 from here, you want to go to here. You don't want to get help from any other queue or anything. From here you want to go here. Can you tell me how we can do it? See, I told you that if these are the two elements, earlier from here we went from here to here very easily, right? How? You can just pop it and then just push it. We went from here to here earlier very easily. This is earlier. Now, if I pop this and push it, actually it won't work. So what I need to do is think about it. Let's just check, right? If you pop it to, this is fine. Then what next? If you pop this again, then that's fine. Then again it is 1 2 3. Okay. So how you can do it? Sorry, my ultimate aim is 3 to 1. My ultimate aim is 3 to 1. So if you pop it, you can push it. If you pop this again, you can push it. Yes, I think we can do it, right? We can do it by 2 times pop and push. So basically, what I'm trying to say, that from here, if I want 3 to 1, you can consider, see, you can say that, okay, you can consider this as a one box. Okay. See, earlier, it was just 1 2, right? So this is just one, I mean, two boxes, and we want to reverse these two boxes, we can do it, right? We want to reverse these two boxes, we can do it. Similarly, you can say this is just one box, this is another box, and if you want to reverse these, then you can do it. You can always, I mean, you should be popping the whole box, in the sense that pop 2. Okay, if you pop 2 and then pop 1, it will be in the same order. Okay, it will be in the same order, and 3 is anyway here, right? So what I'm trying to say, it's very easy, that let's just go from beginning. This is 1 2 3 4, right? This is empty. Now now you ultimately want 4 3 2 1. Okay. See, if these are the two elements, okay, then you can basically remove those two elements. You can write those 1 and 2 here. Now, for those two elements, it's very easy to reverse. How? You can just remove one and then you can just put it here. Now, moment you have three, okay, the moment you have three, now you can consider that, okay, this is one box that you want to basically remove and then put it here. Okay, just think it as a one box, which means you can easily, the first queue is only containing 4, and the next queue is basically, you can have this 1 2 easily, something like in the same order. Okay, I mean, pop it push it, pop it push it, right? So it will be like this. Now you can pop 4 from here to here and consider this whole thing as one box, which means you can easily pop this and push it. Okay, the whole box, which means this is 3 to 1 as it is. Sorry, 4 will be here at the last, and then this is 3 to 1 as it is. Okay, you can push the whole box and then uh, pop and push, which means first you need to do it for 3, then 2, and then 1. So I'm just telling you as a whole box. Okay, so basically you can do this. I mean, you can go from here to here, and the number of NQ or the help that you are taking from the first queue, 0 times, right? 0 times we are taking the help from the first queue. We are first queue in terms of the NQ operation. I'm not doing any NQ from here. Okay, I'm not doing any NQ from here. Is this fine to everyone? Okay, great. So basically 0 is the correct answer. It was a recently asked question, and 0 is the correct answer. Number of NQ they're asking, okay, number of NQ they're asking such that the Q2 is in the reverse order, so 0 is the answer. Okay, now let's solve this question. This question has been asked in GATE DA 2024. Very recently, they have asked this question. This question is basically just saying that you have double-ended queue. You can insert at the first and then you can also insert at the last. You can remove at the first, you can remove at the last also. Okay. So these are the following operations they are performing, and then they are asking the value of a at the last. Okay. So you can just perform the operation. Insert first will basically do this. Insert last 32 at the end. Remove first 10 will get removed, and insert last 28 will be get ended. Insert 70 at the last. Remove first 32, and then remove last. Then basically 17. Then uh, yeah, so basically, basically the value of a is ultimately 17 because the code is basically saying a is remove last, right? Remove first and remove last. So whatever you are removing at the last, okay, which is this 17, so a is 17. Whatever you are removing at the last, a is 17. Okay. Okay, so let's see this question. This is also easy question. So they are saying that we have some code here, and then what this code is doing, you can just answer this question. So suppose you are given some implementation of queue of integers, and then this queue code is given to you. Then what this code is doing? So basically, I'm writing this code, okay, as a pseudo code. So basically, it is doing the removing the front element and taking it into the I, and then inserting that, I mean making the recursive call and then inserting it to a queue. Basically removing the front element, this is the remove the front, and then making a recursive call and then inserting the front element. So basically, let me tell you, suppose you have 1 2 3, suppose this is the front, so you will remove it. Okay, you will remove it, and I is basically 1, so you will remove this. You will remove this, and I is 1. Okay, in this particular call I is 1, but after removing q is basically this, and then you are making a recursive call. Okay, then you will remove again, then I is 2, and after removing, basically you are doing what? After removing, you are again making a recursive call, and then you are removing again, and I is now 3, and after removing, you are again making a recursive call. Now the moment queue is empty, okay, it will basically, you can say, end, I mean there will be the return. Okay, the moment queue is empty, it will return. So it will be returned, right? After return, you are inserting whatever you have, whatever is the value, whatever is the value of I. So I is 3, so you are inserting 3, then it will get returned. So since I is 2, you are inserting 2, then it will get returned, and since I is 1, you are inserting 1. So basically, earlier you had 1 2 3. Okay, 1 is at the front, now you have 3 to 1, and 3 is at the front. So basically, it is reversing. This queue is basically, you can say, reversing the elements. I mean, this code is reversing the elements. Okay, is this fine? So correct answer is B, which means B is saying reversing the order of elements. So initially, if you have 1 2 3, then what this code is doing, it is removing. So you can say in first call, in the first call, it is removing the front element. Now it is 2 3. Okay, and then you can say it is insert. It will insert 1. Okay, at the end. So at the end, 1 will get inserted, if you notice. Then next call, basically because of this FQ, or then what they will do, or maybe I can make a tree, right? Let me make a tree. Basically earlier this is 3 to 1. Now this will be basically doing uh, a call, making a call where it is first removing 3. So I is 3, right? And then they're calling FQ. And once this FQ is and will return, then at that moment they will be basically insert 3. Or you can start with 1 2 3. Then you will see it is basically ultimately 3 to 1. Okay. So so this 1 2 3 is doing two things. I mean, at the first call, you're doing two things. You're calling FQ, you're calling F with remaining element, which is 2 3. And then you will insert 1, right? Similarly, you are calling f with remaining element which is just 3, then you will insert 2, and then you will be calling f empty, right? And then you will insert 3. Okay. So it will return now first you are inserting 3, then you are inserting 2, then you are inserting 1. So you started with 1, 2, 3. Now you got 3 to 1. Okay. So it is doing the reverse. So that's why B is the correct answer. Okay. So till now we have done mostly PYQs related to Q. Now let's just do the PYQs related to stack. Okay. So one thing you might have noticed that most of the questions are basically, you can say, aptitude kind of questions. Okay. So most of the questions are here aptitude kind of questions. Now let's solve this question. This is push pop push pop. So you can easily solve this question, and then you can say B is the answer. So if you follow this push and pop operations, then the value will be, the output will be B. Let's see this question. Which of the following permutations can be obtained in the output in the same order using the stack, assuming the input sequence is this? So basically they are asking that which of the following can be obtained. This is stack permutation kind of question. Okay, stack permutation. So what does this say? That you are inserting in the order of 1, 2, 3, 4, 5 only, but you can pop in any order. So which of the following is possible? For example, if you want to get 3 first, then first of all you have to insert this 3 in the stack 1, 2, 3. I mean, you can insert it or you can push in this order only 1, 2, 3. And then if you want to get this 3, then you have to pop it out. I mean, you cannot push 4, right? Once you push 4, then you have to pop the 4 first. So output will not be 3 first, right? So you have to pop it out, then push 4, you can pop it out, then push 5, you can pop it out. Then the only sequence in which you can pop out is 2, 1, right? But they are saying 1, 2. So that's why it is not possible. Yes, 3, 4, 5, 2, 1 is possible. So this is possible, right? It is possible. 1, you have to pop it out immediately. Then for the 5, okay, you have to push till 2, 3, 4, 5. You can pop out now. Now the next element has to be 4. Okay, next element has to be 4. So that's why this is wrong. 5, 4, 3, 2, 1. See, 5, 4, 3, 2, 1 was fine, but 5, 4, 3, 1, 2 is not fine. Why? Because you have to push all the elements. If you want to get 5, then 4, then 3. This is fine. Then ultimately it is 1, 2. 2, 1, right? But given is 1, 2. So that's why this is also not true. So B is the answer. Okay. So B is possible valid stack permutation. Okay. Now let's see this question. This question is again not directly a gate PYQ, but it is very much related to a gate PYQ. Okay. So there is one gate PYQ which is something like this. So that PYQ was easy, but let's just see that PYQ. Okay. Let's just see this question. So what they are saying, let me just tell you. They are saying, let's suppose there is a stack. Okay. In that stack, it is basically having push and pop operations only. Now, every push or every pop take X seconds. But after any push or pop, you have to wait for Y seconds. So suppose you are pushing 1, then it will take X seconds. But then you have to wait for Y seconds. Okay, here you have to wait for Y seconds. Then you can push 2. Then it will take again X seconds. Then you have to wait for Y seconds and so on. Okay. I mean, in any push, in any 2 consecutive push or push pop, in any 2 operations, there's a elapsed time of Y seconds. If 3 consecutive push operations are performed on the initial empty stack, they determine the total time elapsed from the start of the first push and the end of the push. So basically they are saying that if you are doing 3 push, okay, start of the first push, which means this, end of the push, third push, which is this. So what is the total time? 3 push you are anyway doing, so 3x. Now there's a elapsed time of 2 only, right? In between there's a like 2 elapsed time. I mean, end of the push is here. After that, you will be having a wait time, but they are not asking after that what you are doing. They're just saying immediately after the end of the push, what is the total time that you have taken? So 2y you have taken because there's a interval of y, and then 3x. So 3x plus 2y. Okay. So 3x plus 2y is the correct answer here. Understood? Now, now let's just see this same question, and then they're asking something else. Okay. So I made this is again not a directly gate PYQ, but it is very much related to one of the gate PYQ. Okay. So let's just see what they are saying. The question is same. They are saying the total time elapsed from start of the first push to the completion of the nth push. Okay. So if you are pushing n items, in that case, what will happen? If you are pushing n items, then 1, 2, 3, 4, something like this. If you are pushing n items, then what will happen? See, they are just asking till end of this. So nx that you have taken for n push plus n minus 1 y, right? N minus 1 y. So basically it is nx plus ny minus y, which means C is the answer. Okay. That's also very easy. Understood? Okay. Now let's just see this question. This is little more interesting question. They are saying that you are pushing five natural numbers that are pushed in the sequence, and then they are saying that each push and pop take x seconds and y is the delay. For the third element that is pushed, define as stack life. So they are defining something called stack life as the time from the completion of its push operation to the start of the pop operation that it removes. Basically, what they are saying that you are pushing 1, 2, 3, 4, and 5. Suppose you are pushing this, right? Now they're asking you what is the total time. Okay. Stack life means what is the total time that you have taken from the completion of the push operation of the third, from here. Okay. From here, completion of the push operation of the third till it start of the pop, it's pop. So you can say the see after just immediately after completing it, you will be waiting for y, and then you will be pushing this, right? Then wait for y, pushing this, wait for y. So basically you can say push and wait for y is basically x plus y. For every push you are anyway taking x plus y, right? X plus y. I mean after wait of y you are taking x plus y. Push this, wait y. Push this, wait y, x plus y, right? Then pop this. Again, for every pop, you will be taking again x plus y. Pop this, wait for y. Pop this, wait for y, right? And then you will start popping this. So you can say y plus 4x plus y. So C is the answer. Is this okay to everyone? See, let me have the visual here. I already have the visual. See, once this push 3 is getting completed, you are starting your measurement from here. Y is the first waiting period. After that, everything will be taking x plus y. Okay, you are pushing it, pushing 4, pushing 5, popping 5, popping 4, and then you will end your measurement, which means now pop 3 will start. Okay. So you can say that initial y, after initial y, you are doing 4 operations, 2 push and 2 pop. And each operation basically you can say is taking okay x plus y. I mean x operation operation time, and y is the waiting time. Okay. So initial there is a one y, and each operation is taking x plus y. So that's why 4 into x plus y. Okay. So basically this initial you can write it separately. This initial you can write it separately. After that there is basically 2 push and 2 pop. So for every push and pop you are taking x plus y. So 4 into x plus y. Okay. This initial one is crucial. Now let's just see this question. So they're asking the same question, but they're asking this question for the ith element. So suppose n element you are pushing, they're asking for the ith element. For example, you are pushing 2 elements, 10 elements. Let's suppose you're pushing 10 elements. Okay. Suppose for the second element, or for the fourth element or third element, let's suppose for the third element, they're asking for the stack life. This is the third element. How many elements are above it? 7. If this is the third element, or this is the ith element, then n minus I elements are above it. Or if this is third, then 7 elements. So 7 push and 7 pops. I mean, you have to push them and you have to pop them. So 7x plus y. and 7 basically 14 operations you are doing, right? 7 into 2, 14 operations you will be doing. 14x plus y, right? Plus always remember, before you even start your operations, initial y weight you have to do. So this is the answer. Okay. For ith element, what is the answer? How many elements are above it? Above ith element? N minus I. So total operations, how many? See, 2 n minus I operations. This is number of the operations you will be doing. This is number of operations. Because these many pushes and these many pops. Plus and each operation will be taking, basically you can say, x plus y time. And then initial y also. So this is the answer. Okay. I mean, this is the stack life for ith element. Y plus 2n minus I. So C is the answer. Is this okay to everyone? Let me know. Okay. So y is the initial one, and then n minus I elements are above it, and then 2 into n minus I operations you have to do for each operation x plus y time it is taking. Right? See, y is the initial one. These many operations you have to do. For each you have to take x plus y. That's very easy. Okay. So n minus I push operations and n minus I corresponding pop operations you have to do. So that's how you can solve this question. This question is also easy one. Understood? Okay. Let me know if there is an issue. Okay. Now let's just solve this question which has been asked in GATE. This question is almost same question, but instead of the ith element, they are saying that tell me the average stack life, which means for the ith element. So basically, for the ith element, we have just seen that our answer is something like this. Okay, our answer was something like this, right? This one. This is for the ith element. Stack life for the ith element is this. Now they are saying average stack life, which means you can just take the average of this. So that's also easy. I mean, that's not very tough. So you can take the average. How to take the average? So what you can do, you can find out this value. This will be if you have this summation, it is basically I equal to 1 to n. I'm not writing I equal to 1 to n, but I hope you understood. So 2 into n minus I into x plus y plus, let me write ny. I mean, if you take this summation outside, this will be ny divided by n divided by n, right? And n will get cancelled out. Now this x plus y is a constant multiplicative. You can take it outside. So again, this is x plus y, 2x plus y you can take outside. This is summation of n minus I, right? Divided by n plus y. So basically you have to just find out summation of n minus I plus, I mean, from I equal to 1 to n. So if we unroll this, okay. So if you unroll this summation of n minus I, which will be I, if you put I equal to 1, then it will be n minus 1, and it will be then n minus 2 till 0, right? Okay, till 0, or you can say last element will be non-zero element will be 1. So it is just a summation of 1 to n minus 1, right? It is, I mean, if it is 1 to n, then it is n into n plus 1 by 2, then it is n here is n minus 1 into n plus 1 is n by 2. So n into n minus 1 by 2 will be this divided by n, which means n will get cancelled out. So this n will get cancelled out, and this 2 will get cancelled out. This is n minus 1 into x plus y plus y. Okay. So I will have the typed solution also, but here let me write it. N minus y, n minus 1 into x plus y plus y. So you can just say that this is nx plus ny minus x minus y plus y. So y will get cancelled out. Okay, so you can say that this is n x plus y minus x, something like this. Okay, C is the answer. So basically, finding average actually it might look bit scary, but it is not scary. It is just saying that you just need to find out this average. If you look at it carefully, you can easily do it. Okay, you just have to find out the summation. This average is just finding out the summation, and this summation is also not difficult. If you just unroll it, it is just 0 to n minus 1 summation. Okay, that's all. Okay, have you understood this question? Tell me. If you have understood, just let me know. Okay. This is also easy question. But see, for these kind of questions, you don't have to do that much. You can just put the value of n. For example, if you put n equal to 1, then I think putting n equal to 1 will have different answers for everything. It is x plus y, it is like this, it is basically x only, right? So if you have just one element, then what is the average? For pushing that one element, what is the average stack life? So you after pushing, you will be waiting for y, right? You will be waiting for y, and then you will be anyway start pushing. So basically y should be the answer. So for n equal to 1, y should be the answer. So you can check, okay, C is the answer. For n equal to 1, y is average, right? I mean, just after putting n equal to 1, you can get the answer. Okay, for these kind of questions you can directly put in the exam, but now you know how to solve this, right? Is this fine to everyone? Okay. Similarly, for earlier questions also where you had to struggle a lot, okay, you can put the values. For example, if you are, see here also, I think we were able to put the values. See here also, probably you can put the values, right? So they are asking n m. So basically n equal to 2, maybe m equal to 1. Okay. If you do it, then maybe you will be able to filter out something, right? I mean, you can try putting the values. If you're not able to solve in the exam, you can see if you can do it by putting the values. Understood? Okay. So in the solution also, they have done the similar thing. Y is the initial weight, and then this is there, right? And if you solve it, I think they have solved it. Okay. So they have solved in the almost similar way, right? And then final answer is obviously similar. Okay. Now let's see this. So they are saying that a single array is implementing two stacks. Then what should be the condition of top one and top two? Which means if there's an array, then in this array you should be having two stacks. So basically they want to have two stacks here. That's very easy. I mean, it is not advisable to divide this array into two halves. You say okay, this is the stack one, stack two, because stack one might be having just one element, and stack two may want to have more than n by two elements or something like this. So it is never a idea to put a hard boundary. Okay, so that's why what we do. There's a standard case. We basically for one stack we go from left, for another stack we go from right. Okay. So divide by two, max size divide by two, these things actually are not the good idea, right? Now you just need to check whether top one plus top two is max size. I think that's the case, right? So B is the answer, or D is the answer. Just a second. Since the stacks are growing, now to make the space uses maximum space doesn't need. So either the stack can grow as long as. So what they're asking, let me just see. Okay, condition for the stack full. So they're asking condition for the stack full. The stack will be full when the two of this will be adjacent, which means top one plus one is actually top two. Okay, two of this will be adjacent. Then the stack will be full. So yes, D is the answer. For stack full, D is the answer. Understood? And this max size divided by two, these things will not be the answer. So it's just very easy. You just go from two ends. Now let's just see this question. What they are saying. Stack is getting implemented using supports stack supports basically reverse operation, push and pop. Now, which of the following is true about this stack? A queue cannot be implemented. A queue can be implemented where NQ takes a single instruction and DQ takes a sequence of two instructions. A queue can be implemented where NQ takes a sequence of three instructions and DQ take a single instruction. Let's just see. So basically, they are saying you want to implement a queue using a stack, which is very special stack, which is having a reverse operation also. See, suppose you are pushing 1, 2, 3. Okay. Now, if you want to implement a queue, basically now for the DQ, you have to basically pop this one, right? You have to pop this one. Now, now how to pop this one? You can basically do the reverse first. It will be 3 to 1, and then you can pop it. So it will be 2, 3. Sorry, this is 2, 3. So basically, yes, we were able to DQ one. For NQ, you can directly push. NQ could be directly push. But this whole thing is DQ. But are we done? Are we done? See, now if we NQ some element, actually it is a problem. I mean, I have to leave the stack in the original way, which means if this was, I just need to remove this one. I just need to have the stack 2, 3 like this also. So basically you have to reverse it again. You have to again reverse it. So that it is 2, 3. Now you can basically DQ one more time, then automatically it will be DQing this two. Otherwise, there will be a problem. I mean, you have to leave the stack in such a way. If it is 1, 2, 3 earlier, then after DQ, you only removing two. You are not disturbing other things. Because if you leave this as it is here, okay, your one is fine. But if you leave this as it is here, then what will happen? Then if you DQ again, see if this is the code for DQ, reverse and pop, then reverse and pop actually will DQ 3. Or similarly, if you NQ, let's suppose if you NQ 4, then there will be a mix and match or something like this, right? So you have to keep this reverse. So NQ could be just one operation, but DQ is three operations. So this is one implementation where NQ is single instruction and DQ is three, but here DQ is two. This is incorrect. But they are saying NQ takes a sequence of three. So basically there is no option where NQ is taking one and DQ three, which is, I mean, see, this implementation is fine, but can we transfer all of this load? Okay, see, this is basically fine. This is good implementation. There is no problem in this. But since there is no option matching, so can we transfer all of this reverse load to the NQ? Which means if I want to DQ, okay, I should be immediately DQing. So which means if I have, let's suppose if I'm inserting 1, 2, 3, I need to, at the NQ time, I need to make sure that one should be on the top. Okay, which means when I'm NQing, okay, see, DQ should be something like this. See, stack should be always be having 3, 2, 1. Okay, DQ, let's suppose I want DQ one operation, which is fine. Okay, DQ one operation, I can immediately pop it. But for the NQ, what I want to do, whenever I'm doing NQ, I will be basically pushing it and reversing it. Okay, see, while NQ, we reverse the stack, push the element, and again reverse the stack. Okay, so for the NQ, see, for the DQ, I just want this to be leave for DQ. Okay, if I want DQ in single operation, then stack should look like this at the time of DQ. If I want DQ in single operation, then stack should look like this after NQ. After NQ means for any DQ it should be ready. Okay, I mean NQ should make sure the stack is like this. Okay, after NQ. So how it is possible? Let's just check. Okay, because I don't want to transfer the load for DQ. I want to transfer the load for NQ. Now suppose There is just one element. Okay. For one element, there is not a problem. For the NQ, I'm just doing the NQ. If you do second NQ, if you do second NQ, then this is 1, 2, right? Is this fine? Can you leave like this? No. Okay. You have to push it and reverse it, which means NQ might, okay. For now, you might say that NQ might be something like this. You have to push it, push 2, right? And reverse it. So, 2, 1. Yes, this is fine, right? So basically push 2 and reverse it. This might NQ look, this is how NQ might look like. But if you if you do the NQ again, if you do the NQ again, can you do the NQ directly like this using this code? Push and reverse? No, right? I mean, just check, right? If you do the NQ again, then can you push directly? No, you have to first reverse. Okay. So basically, you have to, if you have to do NQ again, you have to first reverse, which will make it 1, 2, push 3, which will make it 1, 2, 3, right? Then reverse again, which will make it 3, 2, 1. Push and reverse. So basically for every NQ, see these were the two elements, so it was not particularly visible. But for every NQ, we first have to reverse, okay, reverse, then push, then reverse, right? Since this is just one element, reverse, initial reverse doesn't make any sense. You can directly push, but as a code, I should be first reversing, and you have seen why. Because my ultimate aim is to leave like this. Okay, my aim is to leave like this. My aim is to leave like this, right? So if that is the case, then if I NQ1, that's not an issue. I can push it. If I NQ2, then I have to push it and reverse it, right? Now, if I have to NQ3, okay, then I have to push it first. If I push it, see, if I directly push it, then it will be a problem, right? And reverse doesn't work here. So I have to reverse it first, push it, then reverse it next. Then only I can leave like this, okay? So reverse, this is reverse, this is push, this is again reverse. You getting my point? So basically this is how you are doing the NQ. If you want to do DQ as just one operation, because I have to leave DQ just like this, then NQ should be first reverse, then push, then reverse. Okay. If I want DQ in just one operation, then NQ should be first reverse. So 3 operations for the NQ. So Q can be implemented where NQ takes sequence of 3 instructions, DQ can take single instruction. Yes, this is fine. Okay. Earlier also it was fine, where I was saying that you are reversing and then you're popping. I mean, for every DQ there is just 2 operation, and for every NQ there is 2 operations, then also it is fine. Okay. So so if you are doing the NQ, then you can first reverse it and then pop, because sorry, if you're doing the DQ, because if you're doing the NQ, you can directly do 1, 2, 3, right? Okay. For NQ you can directly do, but for DQ you can first reverse and then pop. And then you cannot leave it as it is, because it will be a problem. Then you can reverse it. For here, NQ is 1 operation and DQ is 3. This is also correct. This is also correct. Okay. So earlier I think I said 2 operations, which is incorrect. Basically, it is NQ 1 operation, DQ 3, or you can do here 3, here 1. This is also correct. Okay. They're asking about this. They're asking about this. Okay. If one of the option is like NQ3 and DQ1, which is also correct. NQ3, DQ1. Okay. See, most of these questions are just like aptitude questions, right? Now, see this question. They are having some push. They are having some push and pop, and then they are having Q. They're just asking S plus Q. I think this is easy question. You can do it. Okay, this is coming out to be 86. Now, see this question. This question has been asked very recently. They are having push, NQ pop, DQ pop, DQ DQ. So, and repeat this 3 times. repeat the instruction, this instruction three times. So which is a deque and push. Okay. So pop deque. This is they are doing pop deque, and deque and push one time and then three more times. So total four times this deque push, something like this. So basically, I have the answer: four times deque push. Okay, two times pop deque, and initially the stack and queue will look like this. So if you do all of this, whatever they have told you, then the answer is 8. Okay, this is also easy question. Now, similarly, this question has been asked in GATE 2024, and here also they are basically saying to implement this thing that they are saying that you have S1 and S2. Push to S2 basically pop all these elements and then push to S2. Push to S1 means pop all these elements and pop the top elements. Okay. Push to S2 means pop the top elements and push to S2. Push to S1 means pop the top element and then push to S1. Generate output means pop the top elements from the S1. Okay, so generate output means pop it, but no, but just print it. Okay. So if this is the initial sequence, which of the following output sequence can be generated by the above operations? If you want to generate 100, you have to basically transfer all of this. Okay, at least 400, 300, 200, and then 100 you can output. Okay, you 100 you can output. So in that case, it will be 400. 400, 300, 200. Okay, and then 100 is output, and then this is S2. Then can you have 200? Yes, you can basically pop it and in the stack one, and then you can output it. Can you have after that? Can you have 400? Yes, basically you can transfer both of this to S1, right? 300, 400, and then you can have 400 and 300. So A is definitely possible. So see here, what they're asking, can be generated. So they're saying A is not possible. Let's just check if that is the case. See, you want to have 100. So for that, you will be transferring all the elements, which is 400, 300, 200. Then you can have 100 as output. Then you want to have 200. You can transfer only this to S1, and then you can have 200 as output. Now you want to have 400. For 400, I think you can transfer both of these elements, right? Which is first you will be transferring 300 and then 400, and then you can output 400. Okay, S2 is the capacity of two elements only. So sorry about it. So I've not seen this line. S2 is the capacity of two elements only. So in that case, yes, in that case, let's just see. Okay. If S2 is the capacity of two elements, then what will happen? Can you output 100 first? I think outputting 100 first itself is not possible, right? Because you have to transfer all of this here. So yes, because of this, this is wrong. Okay. So you cannot have 100. But can you have 200? Yes, you can transfer all of this and then you can have 200. Then if you want to have 300, so basically it will be 400 and 300. You can transfer 300 and then you can output 300. So you can solve this question. This is easy, but 100 you cannot have at the first. Okay. So B, C, D are actually the correct answers. Okay. A is not the correct answer here. And these are the sequence that we can follow. Now, similarly, this is some pseudocode which is given, and then they're asking some output. So if you notice, they are saying that this is a empty stack, and then you are basically initially x is 0, you are pushing x, which is 0, to empty stack, and then you're incrementing, and then you're pushing it, okay, till the point that this becomes 8. The moment it becomes 8, you are saying that after that, if flag is 1, then you are basically start popping. I mean, this is a while loop, so you will start popping. Okay. If the popped out element basically is odd, then you will pop one more, and then sum equal to sum plus x. Okay. So basically you will keep on pushing till 8. Okay. The moment x is 8, flag is 1. Now the pop will start. Okay. After that, pop will start. So uh, Now the pop will start, and then you will say that okay, x equal to 8, then you will pop it out, and then summation will be 0 plus 8, which is 8. Now the next pop will start, which is 7. Since it is odd, if it is odd, you will pop one more, okay, which will remove 6. So if you notice, if it is odd, you will pop one more, okay. Now it is 6, right? Now you will pop one more, which is 6, okay. So and then you will sum all of this. So you will sum this. I mean, you are not going to sum this even number. You are only going to sum the odd number. Okay, to 7 here. Now you will pop once again. If it is odd, you will just pop one more time. I mean, you just have to follow the algo, right? And then if you do this, then the ultimately answer will be 24. Okay. Now let's see this question. A program attempts to generate as many permutations as possible on this ring ABCD by pushing the characters ABCD in the same order into the stack. But it may pop the element at any time. Which of the following string cannot be generated? So let's just see which of the following cannot be generated. See, ABCD you can definitely generate push pop push pop push pop push pop, right? ABCD you can definitely generate. DCBA reverse you can generate. I mean, this is possible. This is possible. What about CBAD? If you want C, then you have to push till this point. You can pop it out C, and then B, then A, and then D is definitely possible. What about CABD? So AB you have to push, C you can write here, and then you cannot have A, right? This is wrong. This is wrong. We cannot have A. So D is the correct answer. Now let's see this question. What this question is saying. This is not a gate PYQ. Again, this is related to gate PYQ, but let's just see what they are saying. They are saying there's some algorithm which is having, let's suppose there are some numbers. For each number x and do, push x. So push this number to the stack. If the result is less than 0, okay. So initially, let's suppose result is 0. Okay, initially result is 0. So if the result is less than 0, then make it 0. Otherwise, basically result equal to result plus x. So now result will be 2. Okay. Now do it again. So you just push -3. Okay, you just push -3. Actually push is just for the illusion. I mean, you don't have to push and all, because you are not anyway popping it out. It is just for the illusion. Okay, so don't worry about this. Basically you are saying whatever is the number -3, you just add it. Okay, -3, it will be -1. The moment it is negative, you just make it 0. Okay, the moment the result is negative, you just make it 0. Basically what they are saying, if this is 2 minus 3, 2 minus 1 and 2, right? You just keep on summing the things. So 2 result is 2. If you sum this, result is -1. So you can say that at this moment result is 0. Now just sum these two, okay? Result plus x. I mean, previous result and this. This is 2, so which is fine. Sum these two, this is 1, which is fine. Sum these two, this is 3. So 3 is the answer. I mean, the moment it is negative, you just drop it out. Okay, so C is the answer. Now this is the same question, but they have used a stack here. I mean, this is again not a gate PYQ, but the similar to that. So let's just see this question. What they are saying. They are saying consider a stack that stores the integers. The push si returns a new stack obtained by the integer I on the top of s. So basically, push is basically returning the integer which I just inserted. Okay. For example, if s is initially empty, then after s equal to s2, okay, push returns a new stack. Okay, new stack. So after this, the stack contains 2. So s will contain 2, right? If you are pushing, if you are pushing 2, then basically stack will contain 2, and then after one more operation, after one more push operation, stack will contain 2 3. Okay, the stack, let's just define a function f, which is basically taking a stack and giving an integer. For example, if you have the empty stack, it is giving you 0. If you have something like push, actually push is again a function which will return a stack after pushing. Okay, so this is interesting that it is saying that it is, if it is a stack, then what it will do, it will take a maximum of previous result and 0. If it is basically negative, it will drop. Otherwise it will take the positive thing, right? So for example, let me just do using this. See, initially This is 2, right? So the stack contains, if the stack contains this, then what is the value of fs? Okay. So so just consider that we keep on pushing it. Okay, let's just build it incrementally. So for example, if you push this 2 first, so what is this f of push initial stack? This is, I mean, this is initial empty and then 2. This will basically say that f of whatever is the earlier stack plus 2. Okay, earlier stack is 0 plus 2, it is 2, right? So basically it is 2 minus 3, 2 minus 1 and 2. This is the numbers that we want to insert, suppose. Okay, so f of initial is empty, 2 is nothing but f of whatever is the initial one. I mean, this you are pushing. Okay, this is push plus 2. For the initial, it is 0 plus 2, it is 2. Okay. Now, f of once you push 2, okay, the answer is basically 2. For this, answer is 2. So now you are now going to push minus 3. So it is f of earlier stack minus 3. So earlier stack is actually 2. I mean, the result is 2 minus 3. It is minus 1. So minus 1 will get dropped down to 0. I mean, if it is negative, it will get dropped down to 0. Now, f of 2 minus 3 is actually 0, right? But anyway, now you are going to push 2, which is f of 2 minus 3. I mean, earlier, and then whatever you push. Okay. So earlier it is 0 plus 2, it is 2. So basically, it is same as the previous thing. It is 2, you keep it 2 minus 3 minus 1. Okay. Then the moment it is negative, drop it, add these two, 2, add these two, 1, add these two, 3. For example, see, this is the question that the original question that they have. They are saying that if the stack contains this from the bottom to top, what is the fs? Fs means what is the value of this f of if stack is containing this 2 minus 3, 2 minus 1, 2, right? So basically, you can think that we are pushing these in the incremental order. First, you have empty stack. Then if you push 2, then basically the value of the function will be 2. The moment you push minus 3, the value of the function will be 1, minus 1, but it will be 0. It will drop down to 0. Then adding these two will be 2. Adding these two will be again minus 1, and then adding these two will be 2 minus 1 will be will be 1. Adding these two will be 3, right? So 3 is the answer. Understood? Option C. So basically, whatever is the previous stack, you can just build it incrementally. Whatever is the previous stack plus the new value. What is the value of the previous stack? Okay. So it is 2 plus the new value, which is minus 3. Okay. Now minus 1. Now previous, if the previous is negative, now if the previous is negative, then if it is negative, this is basically previous. Okay. If it is negative, then drop down to 0. Okay. Because maximum will be anyway 0. So C is the answer. So these are the questions of stack and queue that we have. Okay. So mostly these questions, as you can see, that these questions are, you can say, aptitude based questions. Okay. Now, initially it might look little scary to, solve these questions. So, but after you go through this explanation one more time, you will get to understand that what they're asking. But otherwise, don't worry too much about the stack and queue questions, because anyway, those are the aptitude kind of questions. And if they ask something new question, then probably, it will be, you might be able to solve or might not be able to solve. It will not depend on whatever you have solved earlier. Okay. Because it might not depend on that thing, because all the questions are different from each other, and all the questions are bit aptitude kind of questions, right? So I just say that if you have understood everything, then just let me know in the comments. Okay, just comment it out. Okay, and just let me know that if you have understood everything. Okay, thank you so much.